Thank you, Adrian. Before I get on to introducing the panel, although we already know two of the panel already quite well, I just want to comment on the title of this session, Realizing the Benefits of Electrification for Mines. Electrification of mines is not a new technology. It's actually, electrification of mining is really the history of industrialization in the world. It's happened to be in the recent decades, we've shifted more to the use of fossil fuels underground, and the open pit mining has led to more use of fossil fuels above ground. But if you go back to the original development of technologies, the steam engine was developed to support pumping from mines. The next improvement that came along was to use electricity so you didn't have to take a steam engine underground. The next thing that was eliminated was the horses underground. And I think you have to say, although using fossil fuels underground is probably not the nicest thing, having horses underground was probably even worse. So I'd just like to ask the panel here just to introduce themselves as we go around. You want to start, Howard?
Yeah, you know me from the presentation. Howard Boland, Musselwhite Energy Manager.
Dwayne Gadet, Musselwhite Mine. I'm the mobile coordinator.
I'm Kip Sekundiak. I'm the general manager at a company called Prairie Machine and Parts from Saskatoon, Saskatchewan. We specialize in the manufacturing of highly specialized mining equipment, predominantly for underground mining operations, as well as battery-operated electric vehicles.
Dale Ricochi from Sandvik Mining and Rock Technology. I'm the business line manager for underground equipment in Canada, and been involved in the mining industry for almost 30 years, predominantly around equipment. So it's quite interesting to see the focus on the electrification of mines in the past couple of years. Thank you.
And there's one more panel member who's not here, but he is Dave Schmidt from engineering manager with Industrial Fabricators, and he wasn't able to become here today because of a family situation, but he gracefully provided very in-depth answers to all the questions we're going to be talking about. So I'll be reading from those only if the panel here doesn't cover all of his answers. The other thing is, why is this electrification of mining in this conference? Obviously, we could probably have a complete conference just on the use of electricity in mining. But it's true, there's two factors that are really driving electrification. One is the availability of renewable energy and the desire to pull down greenhouse gas emissions. Other things in terms of the underground applications is the environmental improvements. The second long-term trend we're going to be seeing is the days of open pit mining are probably going to start to taper off, and we're going to start to go back underground more where the grades are going to be higher. And as you move underground again within strict environmental requirements, you're going to see more and more of the electrification. But again, there's been many mines around the world in the past, particularly in Europe, that even open pit mining, they would use almost 100% electricity for the crushing, the loading, the transportation, the rail. So the technology is there. It's really to find ways to bridge the gaps between the current practices, developing new practices, and maybe looking at some of the older practices and coming over the resistance. So I think that's where the presentation that we had prior to this session really did give a good example of the hard work it does to introduce new practices. And I want to thank Howard and Dwayne for being very forthcoming with their experiences. I guess quickly, the first question was, what are the main drivers for mines moving to electrification and electric vehicles? And we probably should focus more on underground mining at this point in time for this discussion. Go ahead.
So at Musselwhite, we are a ramp access mine, which means that we don't skip the ore to surface via hoist. And as our ore body gets further and further from the beginning of our conveying system, where our crusher resides, we burn more and more diesel fuel to get it there. So the cost effectiveness is a driving factor from the standpoint of our all-in sustaining cost and managing that and keeping that at an acceptable level. But from my personal perspective, it's workers' health is the main driving force to electrify vehicles underground. Obviously, we have to stay in business and control our costs, but without our most valuable asset, our workers, and you know, we want our people to go home as healthy as they were when they arrived. And so for me, that's the driver. That's what keeps my passion burning.
Yeah, I have to agree with Howard. We spent a lot of time, when I first started this job, we spent a lot of time, I had my workers, they have a shop at 488 level, and they had an issue. We had high DPM levels. We're coming up high all the time. We're getting to where we're respirator fit. The fellows were complaining about headaches, etc. So it really started to affect my people that I look after. And so the first year I dealt with that on a constant basis every day. So I had to go and do a lot of things to get to where we went to filtration, etc. So it took us about a year, and we knocked it down to where we are totally respirator free underground again. And then we, when Howard brought the electric vehicles towards us and talked about this, it really piqued my passion, because I already spent a year dealing with people's health issues, right? And it's for all of us, and it's not for just the mechanics in the shop. It's the miner at the face. It's everybody there. That's who we have to do that for. We talk about ventilation and cost. We talk about people and going home at the end of the day. But the reality is if we can get to a place that we have none of this underground, and we go back to where we have a lower volume, less noise, less ventilation needed, we all win, right? So does it start with 2 vehicles in a mine till we get to all electric vehicles underground? And that's where I'd like to see it go.
Very good, very good. Skip?
I think I echo exactly what these guys have said. A driver in the Saskatchewan potash industry has definitely been not only ventilation, but also lower maintenance costs. Obviously, with lower, less moving parts, electric vehicles are much easier to maintain and keep going. So that's been a primary focus for potash producers to have the same number of trucks underground, and if they can keep more of them going on a daily basis, then it's lower cost to their operation.
Good. Dale?
Just to reinforce not that the health benefits aren't a priority, but what we've really felt strongly over the past few years, and you talk about open pit, but the underground mines, they're exhausting their reserves, and the newer reserves are deeper, and the ventilation challenges to get the volume of air to those depths are becoming increasingly more difficult and more expensive. So to switch to battery, it allows them to actually, in some cases, attack those ore bodies and still be financially viable, as opposed to, they know they have these big ore bodies at depth, but right now they can't build a financial model to get to those because the ventilation costs are just too expensive.
Right, and just another observation, as we go back up to the open pits, some of these open pits are deep enough now in certain climatic regions that the particulate from all the diesel equipment running in the open pits is starting to go beyond there'll be a health concern, and in some jurisdictions it's considered to be an environmental permitting issue as well. So there is an issue with the environmental side above ground as well. Then, of course, as we've talked about, it's the greenhouse gas reduction that's going to come with using, hopefully, renewable energy to drive this equipment versus diesel. Okay, this is just a very quick one, I think. Well, how does electrification fit with renewables integration for mines. And in your case, you're directly on the grid at this point in time, and your grid supply is actually very high in terms of the penetration of renewables on the electric grid, if you consider hydro and clean energy from nuclear. So do you factor that into your calculation of greenhouse gas emissions, Howard?
No, the only thing that's been factored into greenhouse gas emissions has been the electrical power that's been produced by generators on surface. However, with the new cap and trade and the new legislation, the new cap and trade to deal with the new legislation, the rules have all changed so that diesel combusted anywhere is going to be a consideration. But with respect to how electrification is going to mesh with renewables, there's no clear connection at Musselwhite at this point. All I can say is that if in fact electrification required additional energy capacity, electrical energy capacity, which it won't because of what we're going to gain in ventilation, reduced ventilation requirements. I would hope that we would be able to, in the short term, manage those with some renewable projects. However, wind and solar have both been pre-feasibly studied at Musselwhite, and we can't make the ROI work at this point in time for the capex that would be required. At least we can't sell it. So I don't have a good answer for that.
But at the same time, it shows that Goldcorp is thinking about this, and you're conscious of that. That's very good. I'm going to jump ahead to the next question because it's really more applicable to the technology and the application, and it's appropriate for both the miners and the equipment suppliers. And the question really is, how are mines currently testing these technologies, and what have the results been? We've seen the results that you had, Howard, and at Musselwhite. Maybe we can jump ahead to you, Skip, and if you can, what have you been involved with in terms of testing and demonstrating of these technologies?
So, as was mentioned in Howard and Dwayne's presentation, Papa Bravo Innovations designed and supplied the first electric vehicle in 2010, and in December of 2015, PMP made an acquisition and we purchased the Papa Bravo Innovations company. And as of today, we have approximately, we're just nearing 100 trucks in Saskatchewan potash right now in operation. And we have the one truck in the Musselwhite mine that's being tested there. And so for us, our experience has been that the challenges with adopting this new technology, we see a drastic difference between mine sites that have a pretty aggressive approach with their upper management in terms of how they deal with the change, and there's a higher uptake, and there's a greater willingness to test at those type of sites than there are with sites that don't have that appetite for change management.
And Dale, one of your comments was of course, a lot of equipment your company supplies. You're very capable in terms of with tethered equipment, but now as you're starting to move into the untethered or the mobile equipment, you want to comment on that and what sort of testing?
Well, I mean, the mining industry has relied on electric equipment for quite some time for drilling technology. And we also have, even at their Goldcorp property in Red Lake, they have a lot of electrical tethered LHDs. But they're very restrictive, and they do create a lot of challenges for traffic control so that you don't drive over trailing cables. That technology has been around for some time, but they're trying to get the freedoms now of untethered machines because it does provide a lot more, like I say, freedom for operation. The battery technology for underground equipment, at least in the larger size that Sandvik is looking at, is still very much in its infancy. And there are a lot of companies, our customers, that are experimenting with various battery technologies, and they all have some success. From Sandvik's perspective, we're working with the Borden Lake project to produce equipment for this all-electric mine, but it's a steep curve to get there.
Right. And are you getting some pushback? Are there any safety concerns of the batteries underground that you've heard back from your customers?
From the testing that we've seen so far, we haven't seen any. From our perspective, it really drives the approach that we're taking to the technology. It's got to be productive, has to be efficient, but more than anything else, it has to be safe. And the efforts that we've made so far, we've stepped back a few times because the technology didn't meet our testing criteria. We certainly don't want to launch a battery product in an underground environment and risk some type of an event that happens which pushes the technology back 5 years because people become so scared of it. So we were very cautious with regards to that, but certainly, especially with this latest cell phone Toshiba, Samsung scare, it's a topic that's being asked now. What's your safety protocol with batteries? So It's a good question.
Howard, can you have a comment on safety and the batteries underground?
I think as battery technology improves with respect to range and charging capability, so safety with respect to the possibility of an incident improves as well. Critical is the underground infrastructure that's in place to power the battery chargers. Everything that we use is CSA approved over and above the manufacturer's testing and approval, and not only CSA approved but inspected by Electrical Safety Authority inspectors. So yes, there's always a risk for an incident. Usually they come from mishandling and errors made in application rather than because of the technology itself. Not always, but in most cases. So the concern has been raised, but we've been able to reach out to our partners in the electrical safety industry, our manufacturing partners, and our development partners, and receive the assurance that the safety is there.
Okay, that's very good, and I think as experience we'll just take this, and the acceptability is just going to build with more and more demonstrations, and the leadership at Goldcorp and the potash industry in Saskatchewan is very good. I don't want to focus on this too much, but the expectation in terms of diesel savings is really the focus on the amount of diesel that you're saving, or is it the external costs, the effect on the ambient air, the ventilation? Where is the true value of the savings? Is it diesel or is it the other aspects?
I think from our aspect, I believe it's more on what you can save in ventilation. You know, we had talked about the deeper mines and the temperature and all that. You know, that's where we're going to get to. I know in Sudbury there are mines there that are looking at really deep projects, and their main set of machines are going to be all electric because of the heat. So the reality is you know, your health and safety of your workers is going to be number one, and then you're going to also look at ventilation savings and the ability to actually run machines in smaller spaces with higher temperatures. So.
And Dwayne is absolutely right, and just a short example is that at Musselwhite Mine, you know, the Ministry of Labor mandates 100 CFM per horsepower of diesel combustion capability. So we're at the point now at Musselwhite where we're having to deliver 1.1 million CFM to the underground environment. When it's minus 40 degrees C outside, that takes a lot of propane to heat. It takes a lot of electricity to push it down. And the third and the most important constraint that we're facing is we're at the top end of our fan capability. So we can't deliver any more than we're delivering now. So we can't add any more horsepower.
So really, the bottom line is that gallon of diesel or liter of diesel you burn underground is a lot more than what the purchase cost is.
There's also, when you talk about diesel, and because we're a ramp mine and our Toyotas are cage, right? In the middle of the winter when it's minus 40, lots of times you'll walk out of the building and there'll be 15 Toyotas idling for 2-3 hours between shifts. What does that put on a strain on our environment?
Just in the interest of time, I'm going to jump ahead to skip over some of the questions. And because there's a lot of interesting aspects if you get down to the technology of integrating the charging, the shifting of the peak to the off-peak, charging during shift change and things like this, and that allows you to do load management on your electrical systems. There's a lot of technical aspects that are very site-specific. But in terms of the blue skying, well, the question really is, what are the latest innovations or the innovations that are coming that will really increase in more uptake of electrification? Do you want to start with that, Dale?
Yeah, I think probably the driving force behind that is the battery technology. It's changing every year. When I say battery technology, I'm talking about the energy density of the batteries. There's still a long ways to go to compare to diesel fuel. And what a lot of operations are hoping to achieve is to take the diesel fuel tank off the machine and put a battery on and achieve the same duty cycles with battery equipment. And there's just a big gap between where we are today with diesel and what batteries are capable of providing. But the battery technology is continually evolving quite quickly, very much like computers evolve. So that gap, as the energy density of batteries improves, the viability of battery-operated electrical equipment is also going to improve quite considerably.
Mm-hmm. Skip?
Yeah, I would think another major factor in also with the battery technology is some specific technology that we're putting on the vehicles with regards to how we're able to manage the technology, like how we're able to manage the drivability of the truck, for example, from a safety perspective. When we explain to companies like BHP or somebody who has a major focus on the ability to control their fleet differently depending on who's driving the vehicle, with an electric vehicle you have the option to, say, provide the operator with a key fob, and that fob can be programmed to the truck so that the truck can actually be limited on speed. You know, if you have a young operator, that you can limit his speed to half of what the seasoned operator can drive the truck at, for example. Technology like that is going to help the uptake. And also a major contributor right now is probably the charging infrastructure and the standardization of charging infrastructure. We as well as our industry partners are really pushing for this standardization, so that if you use the gas pump analogy Howard was just mentioning earlier today, can you imagine if Ford and GM and everybody you had to have a different handle at the gas pump to fill up your F-150 or your Chevy truck? It would be a total disaster. So we want to get the industry moving towards that standardization, because that's going to play a big part in how fast and how quickly that uptake happens.
Go ahead. Howard?
Yeah, it's not an innovation, but it's what I was going to comment is that by electrifying, we get rid of some of the bad habits that some of the operators use on the diesel-powered equipment, like excessive idling when waiting for a load, when they could shut the vehicle off, but if they do that, they lose their air conditioning, like downgrade acceleration. So a good operator will probably burn about 20% less fuel during a shift than an operator that isn't conscious about things like that. So all those bad habits go away and when we go to the electrics.
We've done a lot of talking and listening about electric vehicles, and some of the items that we looked at in battery technology today. There are companies out there that are looking at. We always talk about the capex and the opex, right? So the capex of an electric vehicle, right off the bat, you've bought your fuel for 3 years. If you were buying a diesel piece of equipment, you don't buy your fuel for 3 years. So some of the ideas out there is you buy the machine, and then you rent your batteries for 3 years. So then you're paying for your batteries through your OPEX, so that you're actually paying for your fuel by the year and not by your brand new machine. So those are the kinds of things that as we move on, we'll have people actually doing that, and then guaranteeing battery technology in 2 years, and say, okay, well, these batteries are done. They should have got you 3 years, but if you wanted it for 25%, we can up, and now we have 45% charge compared to 30%, right? So those are the type of things that I see in battery technology moving forward, because that's how fast this thing will start to roll once we have people out there doing this.
And that is really almost a commercial positioning on the supplier side, the same way Tesla has revolutionized or tried to revolutionize the dealership and service aspect of their electric vehicles. They realized that they couldn't put their advanced vehicle into the typical service shop, and they've also looked at various pricing schemes to deal with the battery issue like that. I guess to maybe as the last question here is, I'll go back to, what are the main barriers for mines investing in electric vehicles and equipment?
This is something that I've been talking about lately a lot. As you know, I manage quite a few of the all the mechanics for mobile equipment, and one of my biggest barriers is the technical aspect. We have mechanics, we have electricians, and then our constant battle is a mechanic will go there and say, no, it's electrical. Electrician will go there, no, it's mechanical. Somewhere in the line here, we need to get to where we're training the people for that job. We really need to get there. We look specifically at our suppliers because that's who they have. But we can't be taking our suppliers' people for our own sites, right? So somehow, if we're moving in this direction, we really need to take a look at who's training the people, what do we need in our industry, and I think we need to take an active part of that in our colleges and our universities or whatever we need to do, and we need to talk to even the Electrical Safety Authority in Ontario to say, look, we need to be able to do this with our technicians so that this fella can test, because that's what our biggest challenge is when it comes to repairing this stuff, right?
Hard?
So having spent about 10 years in a past life as a college professor working with electricians and post-secondary electrical technologists in a teaching capacity, I totally agree with Dwayne, and being involved with joint apprenticeship councils, we've spawned the need for a new trade, and it's going to be half and half, like Dwayne has indicated, so that the technician has the skills to effectively, efficiently, and safely service the new electric vehicles.
And would you say that with the electric vehicles, you're more apt to do less breakdown maintenance and more proactive maintenance?
Our site has always had pride in ourselves in what we do in maintenance. Our maintenance program, I would say, is second to none in the fact that we do proactive maintenance. That is our main goal as a maintenance department at Musselwhite Mine. We need to make sure that that stuff's maintained. It doesn't go out there and break. That is our main objective. And you know what? Going forward, we need to do that, because you get out in the field and you start to try to troubleshoot this thing, and it's dirty and it's a mess and everything else. When you start dealing with that in electrical equipment, that's not the best fit, right?
Howard?
Having said that, and I totally agree, there are so many, there are fewer moving parts on the equivalent electric vehicles, so there's fewer things to go wrong. The motive power, the electric motor, is a much simpler device than the diesel engine. The drive is direct. So given the reduced number of components and the fact that most of them are plug and play, I can see great cost savings with respect to maintenance and breakdown repair.
Skip, can you comment in terms of the training programs that you may have available or what you're intending to come up with for your vehicles?
Yeah, so as a manufacturer, we face the other challenge that these guys face is providing the training and the know-how on how to maintain and keep the vehicle running. And so what we've done is we've tried to use diagnostics, use technology that's currently available. So with our vehicles, you can basically walk up to the vehicle with a tablet or your phone and establish a connection and have a real easy interface for the maintenance individual. Our approach has been not necessarily to have either a mechanic or an electrician. What we're trying to do is make it so that either or can properly maintain the vehicle. And so with these diagnostic tools, we're able to put those tools in the hands of those guys so they can easily see what's wrong with the vehicle, and then making the system modular so that it's small modules that come out of the system that are just swappable, and where you don't have to take the lid off and get right into the meat and potatoes out there at the mining face or in the middle of the mine somewhere. You can just take the module out, replace it with a good one, and then send the module back for refurbishment.
And Dale, do you have something to add to that?
From our perspective, this whole battery drive technology is still very much in its infancy. And I think on both sides, both from our perspective as an OEM, knowing how we're going to support that with our customers, how our customers are going to adapt to it and deal with it, we're all learning. I think our customers are all very willing to stumble along and learn with us because they're very desperate for this technology to evolve very quickly. So they're very forgiving and very understanding, but I think we're all learning how to succeed together, which is very encouraging.
And on this topic of training and whatever, it was very clear in the wind industry that there was a new class of technician required to service wind turbines, and maybe that's where the analogy is here, where it's because if you try to do wind turbines with a fix it when it breaks mentality, you just don't get the high availability that people are expecting when they've adopted that technology. And what sort of availability are you getting now with your equipment at Musselwhite?
Well, are you referring to the equipment we're trialing?
Yeah.
Dwayne is better to speak to the availability.
Well, right now, because we're in the trial phases, and in reality, as you see a few of those slides there are things that keep catching us here and there. But we're confident with our next truck we'll be there because we've solved all our problems really now. So we're probably, I'm going to say, averaging out around 65 with our older trucks. And like I said, we got a couple little items left, and I can't see anything less than 80 after that.
So you've seen improvements since the introduction, and as you get in past the beta testing or whatever. Skip, do you have a comment on the availability that you're seeing in your fleet out in Saskatchewan, which is larger?
In Saskatchewan potash, it's probably much the same. In terms of availability, we would say on average it's a lot higher than what it is with the diesel vehicles. For example, in our trucks, the equivalent of the diesel engine, we call it the master control module. If something goes wrong with the master control module, it's about a 3-hour swap out to take the old one out and put a new one in. Whereas where they do an engine replacement, the truck can be down for 7 or 8 days and unavailable. So just from that perspective, it's a drastic improvement from an uptime availability standpoint.
Okay, good, good. Thank you, gentlemen. That was very good. What I'll do is, Adrian, do we have time for a couple of questions, or? Okay, no problem. Well, thank you very much, gentlemen. It's been very interesting, and